Hi, class. So, welcome to our first um, video recording session or virtual lesson. So, hopefully, you've already been in the lab and have experimented around with some of the stuff, and that you've kind of familiarized yourself with some of those ideas. Um, Anyways, so on the assumption that you've done that, right? What we're looking at in today's lesson is just really basic and simple circuits, and kind of thinking about some of the fundamentals of what we can learn with simple circuits. So in your explorations, right, you've probably seen, right? This is one of the configurations that will light the bulb, right? You've got uh, this end of the bulb here connected to the battery. Let me do that. This end of the bulb here connected to the battery. You've got the wire connected to this end of the bulb. And then you can see current, right? You can see the electrons moving around. And I guess one of the nice things about FET is that you can see the actual motion of the electrons, and that they're moving from the negative end and going around the wire and then back in through the battery. Um, and kind of one of the concepts that we want to look at is, so first off, right, okay, so this is looking at the things with like the actual physical objects, and you can see the bulbs light, and that's really great. The other thing that you may have noticed is that you could press a button and switch things to symbols. So for example, here's what the symbols of all of that stuff looks like. Here's this one's the battery, this one's the bulb, and a wire's just a wire. You can still see the ends where it connects. And the symbols are really good because they're a little bit easier for us to draw than trying to constantly draw uh, light bulbs and big batteries, right? I could draw my circuit and say, okay, look, there's the battery, and I'm gonna hook this wire, and it's gonna go, and then it's got to touch the, this end of the bulb, and then here's the bulb, and then, right? That's not a great schematic, but I could redraw this to say, okay, look, here's the battery, and I'm gonna come around, and the battery is going to attach. I actually just like drawing light bulbs like this, like a resistor. Um, but their symbols for a light bulb looks like this thing. So you can use either or. Um, anyways, uh, just a couple of the big ideas for thinking about what we're learning today is that in order for, right, uh, when you're watching the electrons in these circuits, in order for those electrons to flow, and notice that the electrons are always there. It's not like the electrons magically appear once the circuit starts working. They're always there. But they only start to flow when you complete or close the circuit. Okay, so if you have an open circuit, so for example, if I draw right here's the battery and it goes around, and here's my light bulb, and then it comes back and then I stop, right? That's an open circuit. The current can't flow, even though I do have the light bulb here connected to the battery. If unless that circuit is closed and complete, um, current won't flow and the bulb won't light. So you have to have a closed complete circuit. Um, and one of the things that we wanted you all to notice as you were digging around and looking on and hopefully you looked up some pictures of what the insides of light bulbs look like, right? Because if you have your battery and you hook your wire and you can say, okay, here's my light bulb, and on the light bulb I can either touch the side of the light bulb or I can touch the end of the light bulb. And in this configuration, if I wanted it to light, I'd have to run a wire from there to the back end of the battery and then it would light. But the question is right, what's going inside the battery? Or not the battery, what's going inside the light bulb, right? How is that a closed circuit? And so if we kind of zoom in on the light bulb, there's the glass part, and if I look at the wires, so the whole outer casing is metal, and normally if we were doing this in the lab, we would have touched a wire to the side of this casing, and if you look inside the light bulb, there's a wire that goes, and I'll do this in red. There's a wire that goes from the casing up, runs up, goes through the filament, and then runs down, and then this thing goes all the way down here to the end, and then it touches the end of the knob. And then the cool thing is that in between the casing and this descending wire is an insulator, right? If you look at the bottom of most light bulbs, and I've drawn mine in yellow, but there's like a black, plasticky, rubbery insulator thing with a little metal knob at the end, right? And so this plasticky thing is an insulator to insulate this wire from the outer casing. And so if we were to trace the path of the electricity, it would, right, the current would flow down through here into the side casing. It would hit this connecting wire, then would run up across the filament, go down, and then out, hopefully touching another wire, and then heading back to the battery. But the whole point of all of this, and really the big idea for all of today's work, is that the only way you're going to get a bulb to light or to get a circuit to function is there has to be a closed loop between around the battery. And we're going to, in next time's lesson, so the stuff that I post for Tuesday, we're going to look more closely at each of these components. And we're going to test a few different configurations of circuits and think about what that means and what's happening with the voltage across the circuits. And it'll be helpful to kind of start thinking about and getting used to the schematic way of drawing things, although you will be testing all of your circuits here in this space where you can actually see, right, they have a representation of how bright the bulbs are. And you'll get to play around with all of that stuff in next time's lab if you didn't play around with it already today. So that's basically it for this first lab, is that in order for a circuit to run, you need a power source and you need a closed circuit. And then to know that it's running, you need a way to measure that or to take data on that. And a light bulb kind of provides you, I mean, you can physically see the light bulb turn on and you know the circuit's working. But I guess even now, the fun thing that we would have got to play with had we been doing this in the actual lab is that if you take a battery and if you just run a wire from one end to the other and you don't put anything in between, the energy has to go somewhere, right? This is technically a closed circuit, and so it'll spend the energy of the battery. And without a light bulb in the way to use that energy to create light and a little bit of heat, the energy just gets wasted back inside the battery, and your battery starts to get really hot. And so those of you, if you had done today's lab, most groups end up, they don't burn themselves, but their batteries get really hot, and they realize that, oh, that's called short-circuiting the battery. That's actually really bad for the batteries, and it drains their power really fast. But technically, right, there's a power source, it's a closed loop, so it'll be a functioning circuit. It doesn't do anything unless you're trying to get your batteries warm. Most of the time we'd put something in here like a light bulb so that we could get some light, or a vacuum cleaner or a blender or whatever. But more on this stuff next week. Hope you all have a great time working and studying, and then send Lou and I any questions that you might have. Thanks. Bye.